Hello, this video will focus on the cross-cutting concepts for the Next Generation Science Standards website, currently known in New Jersey as the NJSLS-S. In order to get to the Next Generation Science Standards website, you're going to need to go to your web browser and you're going to type in nextgenscience.org. That will bring you to this home page. There's a few different ways that you can search for information about the cross-cutting concepts. I'm going to show you the home page way first. So if I want to find out information about a particular cross-cutting concept, I'm going to go to this area here. I'm going to click on the drop down, and you'll see that the 7 main cross-cutting concepts are listed here. So you have patterns, cause and effect, scale, proportion, and quantity, systems and system models, energy and matter, structure and function, and stability and change. So say if I want to find out information about which of my standards in my grade level is hitting patterns, I'm going to click on patterns, and then I would go to my grade. Now you can select kindergarten to second grade, which is that kindergarten to second grade band, or you can select a particular grade, kindergarten first or second. For this search, I'm going to click on kindergarten to second grade, because as I discussed in a previous video, there is some autonomy as to when each of the cross-cutting concepts will be addressed within that band. So you're going to click on search, and then that will bring up this window. In this window, you'll see that it's showing all of the DCIs that are addressing cross-cutting concept of patterns. So for instance, in the kindergarten here, you see that patterns is being addressed in that standard. You'll also see listed here, it'll go into more detail about patterns in that cross-cutting concept. Another way that you can search for information about the cross-cutting concepts, or if you want to know how they progress going from kindergarten all the way up to 12th grade, you can click on Search the Standards and you can go to Appendices. Once you get to Appendices, it's actually Appendices G, Cross-Cutting Concepts. I already have that document opened. It opens up to a PDF, but I already have it opened up here so that I can show you some information that I highlighted I thought was particularly important. So on the first page of Appendix G, you're going to see that it will basically define each of the 7 cross-cutting concepts, which are patterns, cause and effect, scale, proportion, quantity, system and system models, energy and matter, structure and function, and stability and change. Then on the second page, it goes into, well, why are the cross-cutting concepts being incorporated in the Next Generation Science Standards? Well, the cross-cutting concepts can help students get a better understanding of the core ideas in science and engineering, and they can help students try to address very complex phenomena by breaking down information, by looking for patterns, looking for connections between systems and system models. By using those 7 cross-cutting concepts, it can help them address more complex phenomena that they find in science. You see, the cross-cutting concepts can help students better understand science and engineering practices. For example, when students analyze and interpret data, in the process of analyzing and interpreting data, they will be looking for patterns and observations or mathematical data, or they'll be looking for patterns and visuals or physical materials that they're looking at. Now, the good thing about the cross-cutting concepts is that there will be repetition in different contexts. So they might be looking for patterns by looking at graphical data, or they might be looking for patterns by looking at mathematical data. So there will be some repetition, and the good thing about that as well is that although they are repeating the use of the cross-cutting concepts, they grow in complexity and sophistication across the grades. So you'll see on the matrix, which is what I like to look at in particular, it's toward the end of the document, you'll see that the matrix gives a good view of how the cross-cutting concepts are changing and progressing as you go from a kindergartner looking at the cross-cutting concepts as opposed to a 12th grader looking at those same cross-cutting concepts. So what's very good about these cross-cutting concepts is they provide a common vocabulary for science and engineering, and they are encountered repeatedly across academic disciplines. So they might be analyzing patterns in math class or analyzing patterns in a book they might be reading, and at the same time they're analyzing patterns in science. So it's not just, geared just towards science, it's something that they can use as a skill in their other academic disciplines. Now, it's very important to know that the cross-cutting concepts should not be addressed separately from the practices or core disciplinary core ideas. That's why all of the disciplinary core ideas, which are our standards, have the cross-cutting concepts, and the science and engineering practices are part of that standard. So they're not a separate entity. You don't have to teach somebody just how to analyze patterns. They're analyzing patterns at the same time that they're learning content where they need that particular skill. So all of our performance expectations reflect on some aspect of the cross-cutting concept, like I addressed, and it's for all students. So really, cross-cutting concepts raise the bar for students who do not have high levels of academic achievement in a particular subject, but they're still able to use these cross-cutting concepts to build those skills to achieve at a higher level. So we go a little further down, you'll see that there is a progression of the cross-cutting concepts as you go across the grade. For example, looking at the cross-cutting concept of patterns, patterns are discernible in the symmetry of flowers and snowflakes, which can be done at a lower grade, and cycling of seasons, which is also done at a lower grade. But then when the students get to a higher grade, to a middle school grade, they might be analyzing patterns of base pairs of DNA. So they're using that same skill in a younger grade, and then also using the same skill but with more complex material in a higher grade. Now, I like to look at the matrix as toward the end of the document. I find it's a good view for comparing how the cross-cutting concepts progress as you go from kindergarten to 12th grade, just to get an understanding. Go further down. Starting on page 13 or page 14, you'll see the performance expectations coded to cross-cutting concepts. So I think this page is really interesting here because I have highlighted patterns, since that's what we were talking about mainly in this video. If you look at patterns here, it tells you that these are all of the standards in kindergarten to second grade that are hitting the cross-cutting concept of patterns. Third to fifth grade, sixth to eighth grade, and 9th to 12th. And they have this labeled and indicated for each one of the cross-cutting concepts. Now, if you go to page 15 of this document, this is the view that I particularly like. So here, NGSS, cross-cutting concepts, patterns again, observe patterns in nature, guide organization, classification, and prompt questions about relationships and causes underlying them. So you can see it shows you very clearly what a kindergartner to second grade will be doing in reference to patterns, that's highlighted here, in comparison to a 9th to 12th grader who's dealing with more complex content. So this matrix also has information for each one of the cross-cutting concepts. I hope this video was helpful, and look forward to having you watch my future videos. Thank you.